Hello everyone. In this video I'm going to walk through how to use the TI-84 Plus calculator to calculate time value of money problems. So I have a set here of 11 problems that I'm going to work through in this video. The first few problems have to do with lump sums. So the first question says here, if your discount rate is 7.5% and you're given the choice between $2,500 today or $4,000 7 years from now, which would you choose? So I'm going to work this out in two separate ways. The first way, I'm going to find the present value of this $4,000. The second way, I'm going to find the future value of this $2,500, and they'll give us the same answer regarding whether or not which one we should choose, but in two different approaches. So for the first way, again, I'm going to calculate the present value of my $4,000. Okay, so my present value is what I'm looking for. My N is equal to 7. My interest rate is equal to 7.5. I'm looking for my present value. And so what I'm going to, my future value is equal to 4,000. So using the TI-84 Plus calculator, I'm going to first turn that on. I'm going to press Apps right there. And I'm going to choose 1 for finance and then 1 again for the time value of money solver. Okay. My inputs look just like what I have here. So my N is equal to 7. My interest rate is 7.5. My present value is what I'm looking for. My payment is 0 because this is a lump sum problem. My future value is equal to 4,000. The payments per year, or the compounding per year, is just equal to 1. And then, since there are no payments, the next one, sorry, I'm getting a little reflection there. The second one here doesn't really matter because we don't have payments in this case. But I'm going to keep it with that beginning, the end value for that one. So I'm going to go up here, scroll up to my present value, and press alpha, and then down here at the bottom, I'm going to press enter to solve for that. So what this says is that my present value is $2,411.02. And you might notice that there's a negative number there. That just means that it's a cash outflow. So I could invest $2,411 today and 2 cents, and I would, if I invested at 7.5%, I'd get $4,000 in 7 years. So my second approach, like I said, is to find the future value of the $2,500. So I'm looking for the future value. Again, my N is going to be equal to 7. My interest rate is equal to 7.5. My present value is equal to negative 2,500, and again, that's because that's what I would invest today. And I'm going to solve for the future value. So my N is 7. My interest rate is 7.5. My present value is negative 2,500. And now I'm going to solve for my future value again by pressing alpha and enter to get $4,147.62. So to answer the question here, which would you choose? Now it's up to you what you would choose. What I would recommend choosing would be to choose the $2,500 today. And the reason being is that if I chose the $4,000 7 years from now and my discount rate is 7.5%, the present value of that $4,000 is less than what I would get today of $2,500. Alternatively, if I took the $2,500 today and invested it at a 7.5% interest rate, I would end up with more than $4,000 7 years from now. All right. The next question asks, if you put $3,000 into an account paying 4% interest, how long would it take you to double your money? So what we're looking for in this case is N, the number of years. we're looking for n. Our present value is equal to negative 3,000. Our future value is going to be double that, because that's what we're looking for. How long would it take to double that $3,000? Notice I have a negative number in here. I have a positive number in here. I'll show you what happens if I don't do that. But the calculator needs to have a negative number and a positive number to calculate the n or to calculate the interest rate. My interest rate is given here, and that's equal to 4%. So I'm going to solve for my n. So I'm going to go through here. I'm just going to put in my variables. My present value, I'll start up here actually with the I is 4. My present value is negative 3,000. My payment is still 0. My future value is 6,000. Actually, and I'm going to make the mistake I said I was going to make. So that should be negative 3,000, but I'm just going to say it's 3,000, okay, just to show you what happens here. And so I'm going to now calculate my n, alpha, and it says there's error. Okay, the error is that I have a positive number for both my present value and my future value. So I'm going to press 2 to go back here so I can fix it. I'm going to press negative this time, 3,000, and now I'm going to calculate it, alpha, and then again press enter down here at the bottom to get 17.67 years. So I want to introduce you to a concept here called the rule of 72. The rule of 72 says it takes, you can calculate the approximate time it takes to double your money given an interest rate by dividing 72 by that interest rate as a whole number. You can estimate the amount of time it takes to double your money by dividing 72 by the interest rate. And again, you're going to treat that interest rate as a whole number. If you didn't, you'd get a really large number here. So I'm going to get out of this area by pressing on, and I'm sure there's a better way to do this, sorry, second, and then on again. And I'm just going to divide 72 by my interest rate as a whole number. 72 divided by 4 is equal to 18. Okay, so what this is saying is it would take approximately 18 years to double your money, which is actually pretty close to our more precise value of 17.67 years. The next question says if you need to have $10,000 in 4 years and have $7,500 to invest today, what rate of interest will you need to earn on your money? So our present value is equal to negative 7,500. Our future value is equal to 10,000. I have 4 years, n is equal to 4. And I'm looking for the interest rate. So again, I'm going to go to apps, and then 1 and 1 again. And it keeps the information in here, so I'll just type over it. So my n is equal to 4. I'm looking for the interest rate. The present value is negative 7,500. There's no payment in this case. My future value is 10,000. I'm going to solve for my interest rate. So I'm going to press alpha, again enter. I need to earn an interest rate of approximately 46% in order to achieve that $10,000. So this next question, there's a calculation that's required. Then the second part of the question is your opinion, and I'm going to talk a little bit about what might influence your opinion in this case. So you're investigating an investment that guarantees a payment of $10,000 40 years from now if you invest $1,000 today. So put $1,000 in today, and in 40 years you're going to get $10,000. Notice here the word guarantees. So this is a risk-free investment. However, you're required to leave the money in for 40 years. What rate of return does this investment pay? So in this case, our present value is equal to negative 1,000. Our future value is equal to 10,000. Our N is equal to 40. And we're solving for the interest rate. So my N is equal to 40. My present value is negative 1,000. Oops. Negative 1,000. My future value is 10,000. I already had that in there from the last problem, so I don't need to update that. And I'm going to solve for my interest rate by pressing alpha and then enter. So we get an interest rate of 5.93%. Now, you might just look at the rates of return. It says here, what rate of return does this investment pay? It's 5.93%. If the average return on the stock market is 9.5%, which is kind of close to that, which investment do you prefer? So you might just look at the return and say, absolutely, throw that money into the stock market because it has a higher rate of return. But the problem, one problem with that is that the average return, that's been the historic average. We don't know that it's going to keep up with that in the future. It could be a lot less than that. It could be a lot more. So there's more risk involved there because it's not a risk-free, doesn't guarantee a return. It's not a risk-free investment. A positive thing about the stock market, though, is that it doesn't require you to leave the money in for 40 years. So if you needed the money in the meantime, you could take money out of your stock market investment. So those are a few things to consider when looking at this problem and thinking about it. The next question is one where we actually have to solve for two problems. So it says here, 18 years from now, you expect to send your child to college. By that time, the tuition is expected to be $20,000 per year. If you expect them to graduate in 4 years and you can earn 8% on your money, how much do you need to invest each year until then to be able to pay for their college? So this is a two-part question. Part one, how much will you need in the bank in 18 years? And part two, how much will you need to invest per year to reach that amount? Assume that tuition is paid in full at the beginning of each academic year. So we're going to start with this problem by calculating the answer as a regular annuity. And then we're going to calculate it as an annuity due, where the first payment is made today and payments are made at the beginning of each period rather than at the end. Okay. So I'm going to start off with a little timeline here, and it's not going to be the entire 22 year, depends on the way you're calculating it, 21 or 22 year period, but we're going to start off at the end. So the last 4 years, you're going to make a payment of $20,000. Okay. And this is, and I apologize, it's kind of squished together there, but what you're going to calculate is that at time 18, how much money do you need to have in the bank? Okay, 18 years from now. This is an annuity due because we make the payment each year at the beginning of the year. So this is an annuity due. So the first step in this problem, how much will you need in the bank in 18 years, is going to be the present value of an annuity due with 4 years, because they will hopefully graduate in 4 years. Will be at the beginning, a $20,000 payment at the beginning of each of 4 years. And the money that is in the account that you have, but haven't spent on tuition yet, will be earning a return of 8%, because that's what your interest rate is here. So the first part 1, I'm looking for the present value. My future value is equal to 0 because at the end of 4 years, there's no money left in the account. My payment is equal to $20,000 per year. I'm going to make that a negative number because I'm going to be spending that money out. I'm going to have this big pile of cash in 18 years, and at the beginning of each of those 4 years, I'm going to pay out $20,000. So I'm going to make that a negative number there. My interest rate is equal to 8%. My n is equal to 4, and I need to solve for my present value. And I know that can be a little confusing here because it's 18 years in the future, but I need to find the present value at year 18 so I can figure out how much I need to make each payment along the way to get to that number. So in my calculator, I'm going to go and make my n is equal to 4. My interest rate is 8%. I'm searching for the present value. My payment is $20,000, and I apologize. That needs to be negative $20,000. My future value is 0. And I'm going to switch this here to the beginning instead of the end because, again, beginning instead of the end because this is an annuity due. So I'm going to press enter there to switch that over. And now I'm going to calculate my present value, pressing alpha, then enter. So in 18 years from now, I need to have $71,541.94 in the bank. So at this point in time, I need $71,541.94. So that's part 1 of the problem. That's how much I need in 18 years. So the first way I'm going to calculate this is making the payments at the end of each period. Okay. So this is a regular annuity. My present value is equal to 0. My future value is equal to this number here, 41.94. I'm searching for the payment. My interest rate is equal to 8. Got ahead of myself there. And my n is equal to 18. So again, I'm going to go to my calculator. My n is 18. My interest rate is 8. My present value is 0. My payment is what I'm looking for. And my future value is the $71,541.94. I'm going to switch my payments to make them at the end of the period rather than the beginning. So that means that my first payment would be a year from now. And my last payment would actually be right here at time 18. I want to solve for my payment. So I'm going to press alpha, then again enter. And so the payment I'm going to need to make at the end of the next 18 years is $1,910.32. So that would be my payment at time 1, time 2, time 3, and so on. Okay. For each year, I'm not writing it in now because I'm gonna solve the second problem now. But that's what I'm gonna have to make at the payment I'm gonna make at the end of each year, including year 18, in order to make these 4 $20,000 tuition payments. Now the next question. So that's the answer to part 2. You'll need to invest $1,910.32. How much if you make the first payment today? So this becomes a an annuity due problem. Okay, it's an annuity that says annuity due, meaning the payments are made at the beginning of the period, and my first payment is made today. So what that means is my first payment is made at time 0. I'm still only making 18 payments. So my last payment will be at time 17 instead of time 18. If I wanted to, I could say, okay, I'm going to make 19 payments, and so my last payment would be at time 18. But we're going to stick with the 18 payments here just to demonstrate that my payment should be less. And the reason my payment should be less is that I'm going to earn an extra year of interest. So that extra year of interest that I'm going to earn is going to lower my required payment at the beginning of each year. So the only thing I need to change here is to go down here at the bottom and change this to beginning. Go back up to the payment and press alpha and then enter. And I see here that my payment is going to fall now to $1,768.81. $1,768.81. And again, the only thing I changed this bottom line from end to beginning. I'm going to flip to the next page now. And now we're going to get into some monthly payments. So the first question says, you're considering buying a 2021 Toyota Corolla. The dealer has offered to sell it to you for $21,000 with payment terms of 60 months and an interest rate of 4%. What will be your monthly payment? So the interest rate is an annual interest rate, but we're going to let the calculator calculate the periodic rate for us. Our payments per year are equal to 12. Okay. Our N is going to be equal to 60. That is 5 years of payments at 12 payments per year. Our interest rate is equal to 4. Our present value is equal to $21,000. That's a positive number because I'm going to receive $21,000. I'm never actually going to see the money, but I'm going to take out a loan. I'm going to receive a $21,000 payment or cash flow from that, and that's going to go to the dealership to buy the car. And then I'm going to make payments out of my own pocket for the next 5 years, and that's going to be a negative cash flow as a result. My future value is equal to 0 because after 60 months, I'm not going to owe anything. So I'm out here again, my time value of money inputs. My N is equal to 60. My interest rate is 4. My present value is $21,000. I'm going to solve for my payment. My future value is 0. My payments per year equal to 12. Now, you see P/Y, that stands for payments per year. And then I'm just going to scroll down, but I'm not going to put anything in for C/Y. The calculator will actually put that information in for you. C/Y stands for compounding periods per year. And since you have 12 payments per year, you also have 12 compounding periods per year. So I'm just going to press down. You're going to see that's going to change to 12. Okay. So it just changed automatically to 12. And this is a regular annuity. When you go out and take out a car loan, you don't make your first payment, at least normally. Don't make your first payment right then. Okay, because otherwise you would need a lower car. You could just take out a lower car loan and reduce the amount you're taking out by that time 0 payment. So I'm going to change that to end, and now I'm going to calculate my payment. Alpha, and then enter, and I get a payment of $386.75. So my next question says, if you need your monthly payment to be at most $320, and I actually faced this when I went to buy a car before, where I had a budget that I stuck to every month, and I knew how much I could afford to spend every month on my car payment, and I already had my terms because at the time I worked for a bank, and so I walked in knowing my terms, knowing my payment, the most I could afford to pay, and so from that I could get the most I could finance for the car. So that's what we're going to look at here. What's the most we can finance today? So we're going to look at the present value. We're calculating the present value. And my inputs are the same terms. N is equal to 60. The interest rate is equal to 4%. My future value is equal to 0. Again, I'm paying the loan off. My payment is equal to negative 320 because it's the most I can pay every month. And so now I'm going to find the present value. So my N is still 60, my I is still 4. I'm searching for that present value. Negative 320 is my maximum payment. Everything else stays the same. 12 payments per year. Payments are at the end of the period. So now I'm going to calculate my present value as alpha and then enter. So the most I can afford to finance today is $17,375.70. The next question says, you are trying to decide whether to purchase a home or continue renting. The home that you are considering purchasing will cost $170,000. You can make a 20% down payment, and you will finance the rest for 3.5% at 30 years, and you will make monthly payments. What is your monthly payment? So in this case, our present value is going to be 80% of that $170,000. Alternatively, if this makes more sense, you could just take 20% of the $170,000 because that's going to be your down payment, and that's going to be $34,000. And you would subtract that $34,000 from the $170,000 because that's how much you're going to pay for the house. That's how much you're going to borrow for the house. Or you could take 0.8 times $170,000. It'll give you the same answer. It's equal to $136,000. This is a positive cash flow because you're taking out a loan, and so you get the proceeds up front. You get the $136,000 up front. Again, it usually doesn't go to you. It goes to whoever's selling the house. But you receive the money, and then you immediately spend it. Okay. My N is going to be equal to 360, which is equal to 30 years. Multiplied by 12 payments per year, because the N is the number of payments or the number of compounding periods overall. So my future value is 0 because I will pay this off. My interest rate is 3.5%. And I'm solving for my payment. So my N is 360. My interest rate is 3.5. My present value is $136,000. My future value is 0. I'm making 12 payments per year, and so my payment is going to be equal to $610.70. And again, this is going to show up as a negative in your calculator because it's a cash outflow. The next question says, the home is expected to increase in value by 4% per year. If you sell the house in 7 years, how much will you get for it? So your expected amount that you're going to get for it, it's going to be the answer to a lump sum problem. You're solving for the future value of a present lump sum. So I'm solving for the future value. My present value is the value of the house today. I'm going to put this in as a negative number, negative $170,000. My interest rate is equal to that 4% right here, and my N is equal to 7. So my question is, how much will this present value grow? What value will it grow to in 7 years if it's earning increasing in value by 4% a year? So in my calculator, I'm going to go to N. My N is now 7. My interest rate is 4. My present value is this negative $170,000. My payment is 0. I'm solving for the future value, but I need to switch this payments period to 1. So now I'm going to solve for my future value by pressing alpha and then enter. And what this says is my house is going to be worth $223,708.40. I'm going to switch to the last page. The last page has kind of two problems on it. They're both non-constant cash flows. I'm going to show you kind of the long way to solve for this and then the shorter way. It may not actually be shorter. But the first question I'm going to go through, I'm just going to directly answer the question. And then the last question, I'm going to take you through a couple of different problems for that question. So question 10 says, a company is considering investing in a project with the following net cash flows. And it gives these positive cash flows for years 1 through 5. If the required rate of return for the company is 15%, what is the present value of this project? So what we're going to do there, we're going to discount those future cash flows back at 15%. So I'm going to use the NPV function in your calculator, and that stands for net present value. And the syntax for this is a little tricky. The first number you're going to put is the interest rate. Then a comma, and the time zero cash flow. And then a comma. And then you're going to put in these curly brackets, curly parentheses. These are going to be all the rest of your cash flows, okay? So your cash flow at time 1 until the end. Okay. And then another curly parentheses, and then a regular parentheses. And I apologize, my curly parentheses came out this time looking like a 3. But that's really the curly parentheses, and I'll show you that to you as we go through the problem. So the one thing that people often miss is this comma right here. Okay. That comma right there. In this case, we don't have a time 0 cash flow, so we're going to put in a value of 0 for that. And then I'm going to show you on the next problem what it looks like when you put a number in for that. Okay. So in this case, what I'm going to do is go to on, and I want to get out of this screen. So I get out of that screen. Here we go. All right. I want to go to apps, and then 1 for finance, and then I'm going to scroll down to 7. So 7 is NPV. Okay. I'm going to press enter, and it gives me NPV, open parentheses. I'm going to go up here. My interest rate is 15%, so I'm going to put that in as a whole number, comma. My time 0 cash flow, as I just mentioned, is just 0. Okay. And then a comma again. If you don't put that comma in, you're going to get an error message. Then I'm going to press second. And you've got the curly parentheses above the regular parentheses. So I'm just going to press my regular parentheses there. And then I'm going to type in my cash flows. So $50,000, comma, $80,000, comma, $70,000, comma, $100,000, comma, and then finally $80,000. And then no comma, but second, close parentheses, and then press close parentheses again. And it doesn't show up too great on here, but this is a curly parentheses and this is a regular parentheses. Okay. And now I'm going to press enter, and it's going to give me the answer of $246,945.35. So the last part of the question says, if the cost of the project is $200,000, should the company invest in the project? And the answer is yes, because the NPV is greater than the $200,000. The NPV is greater than $200,000. So the last question we're going to look at is question 11. And like I said, in this case, what I'm going to do is show you a couple of different ways to calculate things. So in the last case, we went through the NPV function. We typed in all of our cash flows. In this case, I don't want to do that. I'm going to go to stats and then create a list. Okay, so I'm going to go to stat. Stat, and then press 1. And you have L1, L2, L3, L4, and L5. So the first cash flow you put into this is not the time 0 cash flow, it's the time 1 cash flow. And that's important because when we go to calculate our NPV, and I'm also going to show you the IRR, we can put in a time 0 cash flow separate from these. So I'm going to start here. I'm just going to type in the cash flows, 70,000. So you'll see L1, list 1, number 1 is 70,000, and then enter. My next one is 85,000. Let me show you the whole calculator here. And then I press enter again. And I just can go down the list, 95,000, and enter. Oops, and that was wrong, so I'm going to go up and fix it, 95. There we go. 110,000. And then enter. And then finally, 80,000 again. And then enter. Okay. So my list is all in there. I can get out of that now. So now that I have all my cash flows in, I'm going to go back to my main screen and then press apps, then 1, and then 7 for NPV. I'm going to put my discount rate in first, and that's 20. That's what I have down here, comma. 0 is my time 0 cash flow for now, comma. And then I just press second and L1. Remember last time we did the curly parentheses. We don't need to do that now because it assumes that, you know, those cash flows in list 1 are all together. And again, the way I got that is I press second and then the number 1. You can see in the blue shading above it, it's got that L1 list. I'm going to close my parentheses then and just press enter, and it's going to give me the answer of 257, 536, and 1 cent. Okay. So the present value of these cash flows is equal to 257, 536, and 1 cent. So now what I'm going to do, I'm going to show you another way, and you're going to see this later on more. The cost of the project is $350,000. So I'm going to put this in my time 0 cash flow, and that will give me my NPV. Okay. So in this case, I'm going to go apps, 1, and then 7 again. Again, my first number is that discount rate is 20. My second number, I'm going to put in this negative 350,000. Okay. And then comma, and then second and L1. I'm going to close that off then and press enter. And now it's going to give me the net present value if I invest that $350,000. So that's negative $92,463.99. Now in this case, if you just subtract the 350,000 from this 257,000, I'm going to get the same number. Okay. So what this means is if I invest $350,000 today, my net present value, and this is a 7 here, I kind of tried to correct that and made it worse. My net present value is negative $92,463.99, or that's going to be the loss in value to the company based on the results that we have here. The last thing I want to do is calculate the rate of return that I would earn if I did invest that $350,000. Okay. So for that, we're going to go back over here. I'm going to press apps and then 1. But instead of pressing 7 for NPV, I'm going to go down 1 to 8 for the internal rate of return. And again, what I'm calculating here is the rate of return I would earn if I invested $350,000 today and then receive these expected cash flows for the next 5 years. So I'm going to press 8 for IRR. I put 20 in again for my interest rate. Or actually, I don't put 20 in because I'm calculating the interest rate. Sorry about that. I'm going to start with my time 0 cash flow this time, 350,000. And then comma, and then second, and then L1, and close my parentheses. So the syntax is just a little bit different here with the IRR. We don't have an interest rate that we put in because we're calculating the interest rate. we just put in the time zero cash flow. In this case, it's $350,000, and then the list of our cash inflows, beginning with time 1. And it says that the internal rate of return, or my rate of return on this investment, would be 7.83%. So, to answer the last question, should the company invest in the project? The answer is no, for 2 reasons. And they're going to give you the same outcome either way you do this. The net present value is negative, meaning we would actually reduce the value of the company by making this investment. Also, the required rate of return is 20%, but my actual rate of return is far less than that at 7.83%. So this finishes the questions I'm going to go through today. Please let me know if you have any questions.